Hi, welcome back. In this video, we are continuing to look at inferences about the mean. We are continuing to look at a problem we started in our last video that was looking at the question, are farm-raised salmon contaminated beyond the level permitted by the EPA? We did this using a hypothesis test, with the null hypothesis being that they are contaminated at the level permitted, and the alternative being that they are contaminated above the level permitted. This gave us a right tail test. We checked our assumptions and we ended up rejecting our null hypothesis. It did seem that farm-raised salmon appear to have Murex above the level permitted by the EPA. So now that we have rejected our null hypothesis, we have turned to the alternative, which is that the true mean is above 0.08. But I now have a question: how much above 0.8? Are we talking substantially above 0.08? Or is this just a little bit above 0.08? So to do this, we are going to perform a confidence interval. So at this point, I have rejected the null hypothesis, which means that this is not true. So I believe now that the true mean levels of Murex in the salmon are above 0.08. So I now no longer have a null hypothesis. I don't have anything I'm assuming. But I do have this sample from before. So what I am going to do with this sample, so I have N is 150, X bar is 0.0913, and SX is 0.0495. This X bar is my best estimate. This is my best guess. So if you were asking me what the level actually is, and I have just this information to go off of, I would say 0.0913 is my best guess. But I want to do better. I want to get an interval estimate, and I actually want to do a 95% confidence interval. All right, so to do this 95% confidence interval, I would need to go through and check my assumptions. I checked my assumptions for this problem before, so I don't need to check them again. Instead of doing a one sample t-test of the mean, we are going to do a one sample t-interval of the mean. So it's an interval instead of a test, but the assumptions are all the same. So I am going to need that standard error of X bar again, because we are using the central limit theorem. So that is going to be the same thing as before. So that is about equal to 0.004. If you remember back to what we were doing with confidence intervals in our last unit, when we were looking at proportions, our confidence interval is our best estimate plus or minus the margin of error. So I've already identified my best estimate, but my margin of error is going to be a critical value multiplied by the standard error. When we were using the normal model, our critical value was a z. Now that we are not using the normal model, now that we are using a t model, a t distribution, I need my degrees of freedom, and I am going to use a t star. This is my critical value. This t star is very, very similar to what it was when we were looking at critical values for the normal model. So I have a 95% confidence interval, which means my confidence level 95% is in the middle, and I have 0.05 above and 0.05 below. This is going to be positive t star, and this is going to be negative t star. So instead of using an inverse norm, I am going to use inverse t on my calculator. So on my calculator, if I go to the distributions and I go down to inverse t, I'm going to put the area. This is area to the left. So I'm going to put these should be 0.025, not 0.05, right? Because these should add up to be 0.05. So 0.025, and then my degrees of freedom, which are 149. And this gives me a critical value of 1.98. I do want to point out that because the degrees of freedom are included in this, if I were to say, instead of having 149 degrees of freedom, have 49 degrees of freedom, my critical value is different. Or if I had 9 degrees of freedom, again, my critical value is different. So as my degrees of freedom decreases, this critical value is going to increase. So we can't just memorize values like we did with our Z. We have to use our calculator or a t-table to get these. But so I get my t-star value is 1.98 using my calculator. So that makes my margin of error t-star multiplied by the standard error, which I have t-star and I have my standard error. And that gives me, so this is going to be 1.98 times 0.004. This gives me 0.0079. So my confidence interval is going to end up being 0.0913 plus or minus 0.0079. This gives me limits of about 0.0834 to 0.0992. My other option of how I could do this on my calculator is if I go to stat test and I do the t-interval option. I input my mean, my standard deviation of the sample, my n, my confidence level, and I hit calculate. And it gives me limits of 0.0833 to 0.0993. So very, very similar. Either would be accepted. So now how am I going to use this to amend or add to my conclusion? So there is strong evidence that the true mean level of Murex and farm-raised salmon is above the level permitted. We are 95% confident that the true mean level of Murex in farm-raised salmon is between 0.0833 parts per million and 0.0993 parts per million. So what I just added to my conclusion doesn't fight with anything above. It just enhances it and it takes it one step further. So now I'm not just saying that the mean is some level above this. I'm saying that while the mean is somewhere above this, this is the range of values between which I'm 95% confident that it lies.